Okay, so here is all of our information for section 7.2. The essential question for this section is, what are some of the characteristics of the graph of a rational function? So here we're going to be graphing those rational functions that we've been looking at. So our learning targets are to graph simple rational functions. Then we're going to translate simple rational functions. Remember, here we're going to use our a, h, and k. And then we're going to graph some other rational functions. Okay, so the first thing we want to look at is the parent function, right? Because we always start with our parent function and then we can translate it and change it. So our parent function is f of x equals 1 over x. And the graph that makes is called a hyperbola. And you'll see that over here in the blue. It's got two different pieces, which we have to keep in mind. They're called branches. So the domain and range are all non-zero real numbers. You'll see that I have asymptotes. And asymptotes are lines that the graph approaches but never actually touches. So I see I have an asymptote at y equals 0, and I have an asymptote at x equals 0, right? So my axes are my asymptotes for this parent function. So any function of this form, where a is not 0, right, and a is in my numerator, has the same asymptotes, domain, and range as this function, right, as my parent function. As long as I don't have an h or a k, my asymptotes are going to stay x equals 0 and y equals 0. Okay, and the graph will always approach them but never actually touch them. So let's look at this. So I have this new graph. I'm supposed to compare it with the graph of my parent function. So the first thing I want to do is figure out what my asymptotes are. And so I see that it is in this form, a over x, so my asymptotes are x equals 0 and y equals 0. So the first thing I do when I'm graphing is I draw those asymptotes, which we'll see in just a second. The second step is I make a table of values, right? And I kind of just pick some numbers near 0. I don't want to pick 0, right? Because that would mean I'm dividing by 0, which is not possible. And that I know is one of my asymptotes. So I pick some numbers to the left of 0 and some numbers to the right of 0. And then I plug those in to my graph, right? And here's my value that I'm looking at right there. So 4 over x. So when my x is -3, my value is -4 over 3. When x is -2, there's my value. And I just plug those values in and find my numbers. So now I'm going to draw the two branches, right? First thing I do is I draw my hyperbolas, or my asymptotes, right? And we said that those were at x equals 0, so that's this line right here, and y equals 0. So then I know my branches are going to get close to that but never touch. So then I can plot these points. So I'm going to go ahead and plot -1, -4, right? That's this point right here. -2, -2, -3, -4/3. And then I'm going to plot my positive points at 1, 4, 2, 2, and then 3, 4/3. And then I connect those together to form my actual graph. So you'll see that the one that I just colored green, so it's the red and green one, is my new function, right, is my 4 over x. So the blue function is my parent function, my 1 over x. So what do we notice is a little bit different? Well, I can see that they've been slightly stretched. So it's just a little stretch, remember, and we're going to see this again in just a minute about our stretching of graphs. But I have not changed the asymptotes or the domain or the range in this. So it's exact, that part's the same. It just is pulled away from the origin a little bit more. So here is your first monitoring progress. So go ahead and try this and see how you do. So here's our next core concept, right? That last one we talked about, that last example that we did, was dealing with simple functions and simple equations. So here in this core concept, we're looking at graphing our translations. So you'll see some similarities of what you've seen before. So you'll see here I have an a value, I have an h, and I have a k. And again, I have this x minus h, right? So that will also come into play here. And I see that this k is over here all by itself, right? So first I want to draw my asymptotes. And here's where my asymptotes are different. They're not my x equals 0 and y equals 0. But my asymptotes are fairly simple. So my asymptotes here are going to be x equals h, right? And y equals k. So first thing I do when I'm graphing these rational functions is I graph those asymptotes. And then I plot some points to the left and to the right of that vertical asymptote, right? So that h value. So I pick a couple points to the left and I pick a couple points to the right, and then I draw my branches and I can graph it that way. That's the best way to graph this. So now let's look at an example. And here is example number 2 in your book. So I'm supposed to graph this function and state the domain and range. So the first thing I want to do is I want to find my asymptotes. So I always know that my denominator is going to be x minus h. So to rewrite this, it's going to be x minus a negative 2, right? Because I have a plus 2, so I know my h is a negative 2. So my h is a negative 2, and my k value is a negative 1, right? Because that's what's out here all by itself. So that's my first step when I do this. So first I'm going to draw those asymptotes, right? My x equals negative 2, which is this vertical line right here. I'll go ahead and draw that one for you. That one's going to be in green. So x equals negative 2, which is my h value. Then I'm going to draw my horizontal asymptote, which my k is negative 1, right here. Right, so those are my asymptotes. So now I know that my x equals negative 2. Oops, there's negative in there. So now I'm going to pick a couple points to the left and a couple points to the right of negative 2. So then I have, so I'm going to pick like negative 3, negative 4, negative 5, and I'll pick like negative 1, 0, and 1. Something that's easy for you to follow and continue on with. So I'm going to pick those points. They picked a couple different points than I did. And then really all you do is plug them in. So if I pick a 0 for my x, I end up with 0 plus 2, which is 2. And then I have a negative 4 divided by 2, which is negative 2, minus 1 is negative 3. So I can plot that point at 0, comma, negative 3. So I'm going to make my chart, or I can just plot each point individually. And so then once I've plotted those points, I can just go ahead and connect them and see my 2 branches and see where they go from there. So here's your next monitoring progress. So go ahead and give it a try. Oh, one thing on our previous page that we forgot to do was state the domain and range, right? This is going to be very important. Now remember that the domain is all x values and the range is all y values. So when we're dealing with our parent function, it was all real numbers except 0 for both of these. Well, now that I have an h and a k, that changes my domain and my range. So my domain, again, is all my x values. So it's everything going back and forth. So I see that my domain is everything except for this h value, right? Because that's my asymptote. So my domain is going to be all real numbers except negative 2, which is my h value, and the range is going to be all real numbers except negative 1, which is my k value. So this h and k also tell you about your domain and range. Okay, so now here's our next example. This is going to be example number 3. So here I'm supposed to graph 2x plus 1 over x minus 3 and then state the domain and range. Okay, so here's a little bit more complicated, right? We took our simple parent function and we graphed that. And then in the second example, we transformed it. We used our transformations, our a, h, and k, to deal with that and to graph that one. So now I have a little bit more complex rational function because I have a polynomial on the top in the numerator and a polynomial in the denominator. I have multiple terms. So what I want to do is I want to draw the asymptotes. So the first thing I do to do that is I take this denominator and I set it equal to 0 to find my vertical asymptotes, right? That go up and down. Because I know that I cannot have an x value in the denominator that will make the denominator 0. So I solve that for 0 to find my vertical asymptotes. So my vertical asymptote is going to be x equals 3. So I can go ahead and draw that. So my horizontal asymptote is this line right here, y equals a over c. So it's going to be 2 over 1, right? And so this is my 2 right here, and this is my c value right there. Okay, so it's going to be 2 over 1 is 2. So that's where that horizontal asymptote comes into play, and that's how I draw that. So now once I've figured out where those asymptotes are, again, I pick some points to the left and to the right of my vertical asymptote, and then I plot those. And I just plug those x values in and go from there. So if I pick an x value of 0, I substitute in 0 for both of my x's, and I solve and come up with my y value. So then I connect those points together, and I draw my branches and go from there. And then again, I can look at what my asymptotes are to help me determine my domain and range. We had my vertical asymptote at x equals 3, so I know that my domain is going to be all real numbers except x equals 3. And the range, right, my asymptote was at y equals 2, so my range will be all real numbers except 2. So that's the easiest way to find the domain and range from these. So now we're going to look at example number 4. So I'm supposed to rewrite g of x equals 3x plus 5 over x plus 1 into this form, right? So this I can use my transformations on, and then graph the functions. And then I'm supposed to describe the graph g as a transformation of that graph, right? And here we are with our transformations again. So the first thing I want to do is I want to go ahead and do this division, right? I divide the numerator by the denominator. And if this is something that's simple like this and you can use synthetic division, that's fine too. But a lot of times you'll end up just using your long division, right? And so here we go. Let's do this. So I look at my x and I look at my 3x. How many times does x go into 3x? 3. So that's where this comes. 3 times x is 3x, and 3 times 1 is 3. So then I subtract this whole equation, right? 3x minus 3x gives me 0. 5 minus 3 is 2. So that's how I did that long division. Okay, so now I can rewrite that function because this whole number out here is going to end up being my k value. And this 2 that I found becomes my numerator, right? Because this was what's left over. This is my fraction. And my denominator, you see, stays the same. So I just rewrote my function a little bit here. So now I have everything that I know. So my parent in this case would be 2 over x, which I know is going to be a little bit of a stretch over my parent function. My h value was a negative 1, right, because it's going to be x minus a negative 1, so it's a translation 1 unit to the left. And then this k value here, this plus 3, moves it up, so it's a 3 unit shift up. So this also tells me my domain and range of my new function. So I know that my domain would be all real numbers except x equals 1, and my range is going to be all real numbers except y equals 3, because that's where my new asymptotes are from here. Okay, so here's our next monitoring progress. These would be some good things to practice, especially rewriting our functions into this more standard form so that we can use our transformations on that. Okay, so then here's our example number 5. So a 3D printer builds up layers of materials to make three-dimensional models. Each deposited layer bonds to the layer below it. A company decides to make small display models of engine components using a 3D printer. The printer costs $1,000. The material for each model costs $50. So estimate how many models must be printed for the average cost per model to fall to $90. So then the second part of the question is what happens to the average cost as more models are printed? So the first thing we have to do is kind of figure out what we're looking at. So I am told the original cost and the cost to make each model. And so then I'm asked to find the average. Okay, so now I want to write my equation that represents the average cost. So then I can use my graphing calculator to estimate the number of models for the average cost for when it's about $90. Then I can look at the horizontal asymptote to determine what happens when more models are printed. So now let's look at this. So C is going to be the average cost, and M is the number of models. So I know that to find the average, I have to take each unit cost times the number that I print, and then I have to add the cost of the printer, right, because that's a fixed cost at the beginning, and divide by the number printed. Right, so remember finding the average, I add up everything that I have, so this would be the total, and divide by the number of things that I have. But here I'm just adding this 1,000 as my fixed cost of the printer. So now I go ahead and I put that equation, right, my 50m plus 1,000 divided by m into my graphing calculator, and then I can use the trace feature, or I can use Desmos, remember, to find it where it's $90 per model. So find where my y is 90, and then I can see that it's about after 25. So why am I only looking at this part of the graph? Because when I have a rational function, I have two parts of the graph. Well, here, since we're talking things, I can't have a negative number of models that I print, and I can't have negative So I can get rid of that part of my graph and only focus on the positive. So let's go ahead and actually look at Desmos and see what that would look like. So let me clear this out. So here we are going to have, was that 50m plus 1000, and we're going to close that in, divided by m. I don't want sliders. Let me just double check that that was my equation. Yep. So you see, I can't see it currently. Oh, going the wrong way. But once I zoom out, I should be able to see my graph. Oh, I forgot my. There we go. Now it's not happy at me either. There we go. I zoomed way too far out. Okay, so again, I have this negative part of my graph, but I don't care about it because it doesn't actually matter because I can't have negative things. And I wanted to figure out when y equals 90. So then I can just plug that in, and I see that when x is 25, my y is 90. So that tells me that once I've made 25 things, my average cost will be $90. So then from there I can continue to look at my model and see what happens. So here they're using a graphing calculator to create tables to show that my average cost approaches $50 as more models are printed. If you don't want to use your table, you can continue to use your Desmos function and use this slider now that you've created it here. So we want to move this to where approximately where you see it's not going to cross anymore. So here again I have my black line, my y over the other one. So I can see that it's going to approach $50. So as I continue, it's getting closer and closer, but it's never going to touch. So I can use that to estimate that it's going to approach $50. And this I can do without creating the table and without having to use the actual graphing calculator. I can still use my Desmos to do that. So here is your next monitoring progress. I really want you to try this. So what happens when I change the cost of the printer? How does that change the answers to the other things? So now that we've gone through this section, let's look back at our learning targets and see how we did. So first thing was to graph simple rational functions. Those simple rational functions looked a lot like this, my a over x, right? My parent function, where I have some value, some number over x. These are considered our simple ones. So then from there, I translated those simple rational functions. I took the a, h, and k, and I translated my graph up and over, and I used my a value. And then I was able to graph other rational functions. That other rational function is my word problem, dealing with my 3D printers, right? That's a different kind of rational function that we didn't write as a simple function, but we could still graph it and use technology to help us. So now that we've gone through this, please go ahead and work on your homework for 7.2.